Hi everyone and welcome back again. In this video, I'm going to show you how to check a number is a prime or not, just like checking prime number. And so again and again, why I'm practicing more about this kind of problem based on it will be solved by for loop or control statement, because control statement is so important for you. So it can help you to understand the looping very well. And I'll try to use here nested if. Okay, so let's open a new class first. Okay, under Java application, I just open a new class. It will be prime check, prime number checking. Okay. Mm. Now, at first, I'm going to show you the theory part. Whenever we can call a number is prime or not. We have two condition for a number to become a prime. The first condition is, for example, 5 is a number. 5. I want to check it, is it prime or not. So at first, this number should be just like divide by any other number, and remainder should be 0 to become prime. If remainder not become 0, like for example, I don't say 5, I just say x. If it's not become 0, that time it will not be prime number. But except 1 and this number, x can be prime when if we divide x by any other number without x and 1, like without x and 1, try it again. And remainder must be 0. So we have to get remainder 0 to become a number is a prime, and that time we cannot divide x and 1, let me say this number and by 1, that time it can be become a prime number. For example, if I want to say, for example, like 7, I want to check the 7 is a prime or not. 1 cannot, I cannot divide by 1, I have to divide by 2, divide by 3, 4, 5, 6, until 6, because 7 will be this. So if I divide by 2 to 7, remainder is not 0, 3 also remainder is not 0, 4 remainder not 0, 5 also remainder not 0, 6 also remainder not 0. That means it's become a prime number. But how about if I want to look for 6? 6 will be 2, 3, 4, 5 until 5. If I divide by 2, okay, remainder 0. 3 also remainder 0. But though I already change, after by divide 2 is already remainder 0, I don't need to check anymore. I just will continue. I just can say it that it's not a prime number. Okay, so now I'm going to write code. So at first I need to create a main method. Then I need to take input scanner class. I need to create a scanner class. Okay, is equal to new scanner, and then system dot in. Okay, I can import it. Okay, system s will be capital letter. Java is the case. case sensitive language. So you have to be careful whenever it's a small letter, whenever it's capital letter. Okay, so now let me at first create a variable that is x, integer x, and then I want to just print it, take a space to get user input. Make a space, enter the number. Okay, enter the number, and then I need to get input from user. So x is equal to input dot, it will be next int because it's an integer x, next integer. So until now it's done. Now I want to declare another variable that's called count. Just I integer count equal to 0. I just initially think it's 0. Why I take it, I will, after that you will understand. Okay, now we know among this theory we can say something. One is a special case because one is the number that can divide by 1 and the number is also 1. So 1 will not be a prime number, not prime number. 1 not prime number. And now let's come 2. Although 2 is odd number, but 2 is a number that can divide by 2 and 1 and can get only remainder 0. And there is no any other number, any other integer that I can divide 2 and get remainder 0. So 2 will be also prime number. For prime number, this 2 is a special case. So at first I can say if, and also 0 also not a prime number. 1 and 0 is not a prime number because everything you can divide to 0, it will be infinitive. So 0 also is not a prime number. Will be 0 or 0. If you can divide anything by any number to 0, it will be 0. So this is 0 0. So at first I can say if x equal 1 or equal 0. So that time my number should be not a prime number. Not a prime number. And now again, I can say other thing. It's like else if whenever the you see num sorry x is equal to 2. That time what can we say? This is a special case. So that time we can say it's a prime number. It's a prime number. X equal to 2. So now the third case in else if okay, whenever x will be more than 2, x will be greater than 2. This is case what happened there. That time I need to use a loop. So for all number that's bigger than x. So for integer I is equal to 0 and I will start from 3 because 2 is 3 and I will finish until x. Until x means it's the before the x. So means the x minus 1 we can write like this. Minus 1 equal we can use. This one can, but I don't need to use this. I just say just only x. Only x, and it will increase 1 by 1 by 1. So inside there, for I need to use now for condition. There will be some number from 3 to until the end, until infinity. Some number will be prime and some number will be not prime. So there is two cases. So if x divide or x modulus I, because I will start and x will be input, I equal 0. This means any number that can divide x whenever remainder becomes 0, that time we can say, we can just count it. So we can even we can count it here. I'm not going to print here for it's first. We just want to count it. Count. We're going to use to count it. This is for if it's 0. It will count. After break, then is the looping off and for loop will be off. Now another I say if count equal to 0, that means it's not get any number that can get the any number that can after divide that remainder will be 0. So that time is count equal to 0. It will count. If one time they can get 0, that means different thing. But if they don't find any number except that number and 1, so that time it will print when the count 0, it will print the number is prime number. If count is equal to 0, this is inside this if is inside this if, that means it's the nested. Okay, for loop will close here. I mean another bracket. Now this for count if counting 0, but else if counting not 0, else means this is inside this if. Else we can print number is not prime number, not a prime number, not a prime number. So now I need to get it as a only print so that I can put the input on same line. Now let me see. This is for example 5 prime number. Okay, it's because I put inside this this inside for loop, so it's came 2 times. Okay, I am going to close it. Now I just if I try to just here, if I give you one other bracket, this means it will be for loop will close here, then these two will working belongs to this else, not inside for. Else if and this if and then is working. So now if I run again, 5 or I just straight to 7 is a prime number. If I want to put here the number is a 8, for example, not a prime number. So I think that's all you understand until now. If I that's all. At first I take user input, I check if 0 or 1 it will be not prime, then if 1 if 2 it will be prime number. If more than 2, then we will start our calculation divided by I is equal to 0. That time we will count it first and then we'll break the loop, because if one time we can get it count, that's okay. I don't need to check for all number. If one time we can get the remainder is equal to 0, that's enough. So then we can say that if count equal to 0, we can use the prime number. If count not means else is equal to is not a prime number. So that's all. Thank you.